Hey guys, yesterday we were working on simple events probability of one event. So today we're going to kind of move into probability when there's more than one event happening, okay? And we are going to create sample spaces. Now there's a couple of ways we can do sample spaces. The one we're going to focus on is a tree diagram because that's generally what you see, okay? Some of you may have done these before, so it may seem kind of easy. If this is confusing, my suggestion is watch it more than once so that you can kind of follow what's happening, okay? The idea is easy, but it can get a little overwhelming. So this says, a number cube has 6 faces. When you roll a number cube, there are 6 possibilities. An outcome is any one of the possible results of an action. The set of all possible outcomes is the sample space. It's a list of all of your possible outcomes. Organized lists, tables, and tree diagrams can be used to represent the sample space. So generally, y'all will see a list or a tree diagram. Personally, I like using a table or what I call an area model. A tree diagram uses branches to show the total number of outcomes. So we are going to kind of scroll down here so you can see what's going on. So hopefully this looks like something maybe you have done before. So draw a tree diagram to determine the sample space when a coin is tossed and a number cube is rolled. So guys, what we're doing here is 2 things. So we kind of talked about that yesterday in class. How many things we're doing? We are flipping a coin and we are rolling a number cube. We're doing 2 things. So this makes our probability a tiny bit more challenging, okay? So what we're going to do here is we're actually going to come up with a question from this. I want to know the probability of, let's say, I want the probability of flipping heads and getting an even number on the number cube, okay? Flipping heads and getting an even number on the number cube. So our job is to figure out every single combination that we can get when we flip a coin and we roll our number cube, okay? So notice they started with a coin, okay? We can get a heads or a tails, okay? So that's 2 possible outcomes, a heads or a tail. Now this is where I want you to listen. If I get a heads, let's say I flip a heads, then I roll the number cube, I can get a 1 or a 2 or a 3 or a 4 or a 5 or a 6. So guys, I can get a heads and then a 1, I can get a heads and then a 2, a heads and a 3, a heads and a 4, a heads and a 5, and a heads and a 6, right? These are, I cannot think of any other possibility if I flip a heads first, okay? 1, 2, 3, 4, 5, 6. I have 6 different possibilities if I flip a heads first. However, I might not flip a heads first. I might flip a tails first. If I flip a tails first and then I roll that number cube, I can get a 1, a 2, a 3, a 4, a 5, or a 6, okay? So we can get tails with a 1, tails with a 2, tails 3, tails 4, tails 5, tails 6. I want you to think a second. If I flip my coin, I get heads or tails. Once I get that, this is what I can roll on the number cube. There's no other combination that I could get. Okay, so I want you to look at all these combinations. Okay, and officially, we have 12 total possible outcomes. Okay, let me switch colors here. I have 2 outcomes for a coin, and a number cube has 6. So I do 2 times 6, which gives me a sample space of 12. There are 12 outcomes here, okay? Now, I want to get heads and an even number. So remember, even means it's divisible by 2 with no remainder, 2, 4, or 6. Okay? So what I want to do is I want to find everything with that's heads with an even. Okay? So heads with a 1, heads with a 2, so that's heads even. Heads with a 3, that is not even. Heads with a 4, that works. Heads with a 5, nope, because 5 is odd. I need even. And heads with a 6, this is even. Okay? So right now, I have 1, 2, 3 outcomes. Okay? So then I have my tails. Remember, I need heads with an even. Well, this is tails. Nope, 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 nope. None of these are heads. Okay, so this goes all the way. So we're needing 2 things here because, guys, we're doing 2 things. I need a heads first, and then I need an even. So when I do this, guys, I can tell our total possible outcomes, that total sample space is 12. Heads with even is 1, 2, 3. Okay? And I get 3 over 12. And when I simplify that, I get 1/4. Okay? So another way we do that, guys, and this gets into what we're doing next, is compound events, guys. These are what we call independent events. When I flip a coin, it has 0 bearing on if I'm going to get a 1, a 2, a 3, a 4, a 5, or a 6. What I mean is, let's say that I flip a coin and I have a tails. Because I have a tails, that doesn't mean I'm going to roll a 1. That doesn't mean I'm going to roll a 2. That doesn't mean I'm going to roll a 3. This does not affect this. So these are called independent events. Okay? Coins, number cubes, always independent. Spinners, okay? So what normally I do is I'll say, okay, well, first thing I want is a heads, okay? So I'm going to do event 1. Event 1 is a heads, okay? So E1. When I want a heads, I can see on my coin I have 2 sides, heads, tails. So the total is 2. I have a heads and a tails, right? What's the chance of getting a heads? Well, one of the sides is a head. So you are going to find just the simple probability. The simple probability. I want a heads. There's 1 heads on a coin. There are 2 sides on the coin. Okay? Event 2 is even. So I have, I'm going to do it down here. 1, 2, 3, 4, 5, 6. Of these, which ones are even? Nope. Yep. Nope. Yep. Nope. Yep. So even is 2, 4, 6. How many numbers are even here? 3 out of 6. Now, one thing I know here is that this will simplify by 3. So I'm going to divide by 3. Divide by 3. 3 divided by 3. 6 divided by 3. And then, guys, we do E1, E2, multiply. E1, E2, multiply. Find your simple probability, and multiply. Get the same answer, okay? So that's just kind of an example of what is coming. I love probability. It takes a little bit to get used to it, but it's going to happen. Okay. So this one says, use a list or tree diagram to show the sample space for each action. Okay. Now they left off a line here. I remember that drives me crazy, but there is a line left off. So I'm going to put it right there. Okay. So basically, it says use a list or a tree diagram to find the sample space for each action. Okay, so here, my sample space, it just doesn't say anything about how many times I do this. Okay, so if I just spin the spinner one time, I can get an A, a B, or a C, correct? We talked about this yesterday in our lesson. Just list. The sample space is your list, okay? Now over here, I'm going to do this a little different. It says sample space. It only doesn't really talk much about how much we do, so I'm going to say we spin it one time, I can get red, purple, blue, yellow, or green. That is my sample space, okay? Now I'm going to do a sample space for a coin 3 times. So each time we want a tails and a heads, right? Or heads and tails, and I'm going to always leave it in the same order. So when I flip this 3 times, guys, you're going to be surprised at my outcome. If I was to say, what is the chance of getting a heads 3 times? You'll probably be surprised, okay, at my answer. So, coin. First one, I can get a heads or a tails, right? First one. Now, if I get a heads first, when I flip it again, I can still get a heads, right? It doesn't disappear off the coin. I can get a heads or a tails. But I might not get a heads first. I might get a tails first. So this is a way of showing you every possible outcome. Heads and tails. So basically, guys, I could get heads, 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 tails, tails, heads, or tails, tails. Now, I'm going to flip a coin again for the 3rd time. So let's say the first time I get a heads and the second time I get a heads, I can still, on the 3rd try, get a heads. And the second time, or I could get a tails, right? I could get a heads the first time, heads the second time, heads the 3rd time. Or, so H, H, H. Or I could get heads, heads with a tails, right? And then on this one, it's saying I could start with the heads, then get a tails, heads and tails, but the next one I could get a heads or a tails, right? Each time it's like continuing. So heads, tails, heads, heads, tails, tails. Okay? But maybe I don't start with the tails at all. I get a tails first. So I could get tails, then a heads. And remember, even if I get tails and heads, the next one could still be a heads. Or it might be a tail. So I could get tails, heads, heads. Or tails, heads, tails. Okay? Or I could get tails, tails. If I get tails, tails, can't I still get a heads? Tails, tails, heads. Or tails, tails, tails. Okay? So if you look, I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 total possible outcomes. One of them is a heads. One of them is a heads. As far as heads, 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 only one. This is the only one where it's heads, heads, heads. Okay? 1 out of 8. So if I want heads 3 times, guys, it's not like 1/2, okay? It's 1/8, okay? Last question. Probably won't even have time. Bailey will roll a number cube and flip a coin for a probability experiment. The faces of the number cube are labeled 1 through 6. The coin will land on the heads or tails. If Bailey rolls the number cube once, flips the coin once, which list contains only the outcomes in which the number cube lands on a number greater than 4. Okay? So we only want the 4. Everything greater than 4. That means we do not